So yesterday we talked about angle rotations and reference angles and things like that. So today we're going to use that to help us talk about so we're going to use angle rotations and reference angles to help talk about trig ratios, things like sine, cosine, and tangent. And if you remember sine, cosine, and tangent from last year, those work in right triangles. So you're going to see in your notes that we have a right triangle here. And we actually look at this right triangle in what's called a circle, a unit circle. And that's because I told you in the first video that trigonometry deals with something called circular functions. Now, you're going to notice that the hypotenuse of this triangle is labeled r. Why? Because that hypotenuse actually is the radius of the circle. The base of the triangle is labeled x because it's the distance along the x-axis. And this vertical side is labeled y because it's the distance along the y-axis, essentially the distance going up or the distance going down. So we're going to work with the circle and we're going to work with this triangle that has x, y, and r for this entire lesson to talk about how that relates to trig ratios, things like sine, cosine, and tangent. Now if we look at the first example, it says sketch the rotation angle that goes through the point -5 and 12. Okay, so if I look at this, well, -5 is over here and 12 is up here. So -5 and 12 is this point up here. It's up here in the second quadrant. Now, to create a right triangle with this terminal arm, we always draw a line down to our x-axis. We know that this distance from the center to this edge is 5 units because it goes -5 to the left, and it is important that we put a negative here because we're going along the negative x-axis, and that'll affect sine, cosine, and tangent as well. This distance going up is the y coordinate here. It's going up a distance of 12. Now we need to know the radius of this particular circle or the length of that terminal arm, and what we do to find that is we use Pythagorean theorem. We know the a and the b, we know the legs of our triangle, so we're going to go 12 squared plus -5 squared equals c squared. That gives us 144 plus 25 equals c squared. 144 plus 25 is 169. And to find c, we take the square root of 169, which gives us 13. So this hypotenuse is 13. So in this particular triangle, x is -5, y is 12, and r is 13. So we're going to do a second one. It says we have a point that's at -2 and -6. So that point's down here in quadrant 3. Again, we make our right triangle by drawing a line from the end of our terminal arm up to the x-axis. So the distance along the x-axis is -2. The distance along the y is -6. And we're going to use Pythagorean theorem again to figure out our radius. So we get -2 squared plus -6 squared equals c squared. Well, this is 4 plus 36 is c squared. This is 40 equals c squared, because if you add the 4 and the 36, you get 40. Now to get c, we have to take the square root of 40. Now we always want to write our radicals in simplest form. So we now have to simplify the square root of 40. It's the square root of 4 times the square root of 10. Square root of 4 is 2, and we're left with a root 10. So one of the skills you need to be able to have in this unit is you need to be able to find the hypotenuse of this right triangle using Pythagorean theorem. Now, if we flip the page, we need to do a quick review of our 3 primary trig ratios, which are sine, cosine, and tangent. Hopefully you remember that when we worked with right triangles, sine was the opposite over the hypotenuse, cosine was the adjacent over the hypotenuse, and tangent was the opposite over the adjacent. And last year we had an acronym to help us memorize that or help us remember it. It was SOHCAHTOA. S-O-H-C-A-H and T-O-A to remember these things. So if we now relate this to the X, the Y, and the R, sine is opposite. Well, opposite angle theta is Y over hypotenuse. The hypotenuse of this triangle is R. So sine is Y over R. Adjacent over hypotenuse is cosine, so our adjacent side is X over R, which is our hypotenuse. Tangent is opposite over adjacent. If we go to our angle theta, the opposite is Y, the adjacent is X. So tangent's Y over X. These three ratios with the X, the Y, and the R are going to be really, really important for the rest of the days that you do trigonometry. You're going to use those things. So it's really important to memorize those things, to remember them. You can come up with some sort of acronym, or you can just remember this triangle that has the Y, the X, and the R, and remember SOHCAHTOA. And SOHCAHTOA helps you do opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Okay, so if we look at example number 3, it says the point 15 and 8 lies on the terminal arm. So that's this point on our terminal arm, which helps us form our triangle. So this is the point 15 and 8. It says calculate the value of R in this triangle. Well, we know the distance along X is 15 because our value in our point is 15, and we know the distance along Y is 8 from our coordinate. So how are we going to figure out R? Well, R is going to be figured out by using Pythagorean theorem. So we end up with 15 squared plus 8 squared is c squared. 15 squared is 225. 8 squared is 64. And if we take 225 plus 64, let's take out our calculator, that gives us 289. So to get c, we have to take the square root of 289, and that gives us 17. So this distance r is 17. So now what they want us to do is they want us to write the ratios for sine theta, cosine theta, and tangent theta. So sine theta is actually y over r. It's opposite over hypotenuse, which is actually 8 over 17 in this particular triangle. Cosine is x over r, adjacent over hypotenuse, which is 15 over 17, and tangent's y over x, which is opposite over adjacent, so it's got the ratio of 8 over 15. So hopefully, if you're given a coordinate on a terminal arm, you're going to be able to draw your right triangle and label the lengths of the sides, use Pythagorean theorem to figure the length of your hypotenuse, and then finish finding your ratios.